Hey everybody, welcome back. We're in part 4 of chapter 14. So now we're going to get into more of that physiology of what's going on. We've talked about the structures and some of their basic functions, but now we're going to really get into that physiology. So I mentioned earlier that the first part of digestion is ingestion, or placing food into the mouth. From there, food is going to be mechanically broke down. So we're going to chew it up. That's part of that mechanical breakdown. Your stomach is going to churn, and your small intestines are going to move food back and forth in a process called segmentation. We're going to swallow the food bolus, the soft ball of food, down through our pharynx, oral and laryngopharynx, through our esophagus and into the stomach. We're going to continue with the mechanical digestion, but we're also going to be chemically digesting. So chemical digestion starts in the mouth with the saliva, and it's going to continue on in the stomach. Then food moves into the small intestines, where we still have mechanical digestion, that segmentation and movement, but we also are going to be chemically digesting the food using enzymes, breaking them into their smaller subunits. And we're going to start absorption. So the small intestines is where the majority of absorption of our nutrients comes from. Absorption occurs into the capillaries as well as the lymphatic vessels of our small intestines. This leads us to the large intestines, where we're going to have absorption of water, as well as the production and absorption of certain vitamins. And the remaining material that ends up in the rectum is fecal matter, or poop, which we're going to release through our anus in a process known as defecation, or defecation is the best word for it. Oh, there we go. So what is this peristalsis, or churning? Peristalsis is the movement of materials in a direction caused by the slow contractions of smooth muscle. And so smooth muscles contract, pushing that ball of food down, and then the next segment will start to contract, pushing the food further down and further down until it enters the stomach. This is segmentation, which is very much like churning, where materials move from one section to another section, and they just continuously move back and forth. This helps to break food down even further. So mechanical breakdown, which also is known as mechanical digestion, starts in the stomach. And I showed you that where food mixes with the saliva in your mouth and gets mechanically broke down by your teeth, and the chemical breakdown starts in your mouth as well for carbohydrates. So mechanical digestion prepares food for the chemical digestion by the enzymes. So digestion occurs, or I should say, chemical digestion occurs then when enzymes chemically break down the large building blocks like proteins the large macromolecules like proteins and carbohydrates into their smaller subunits, or their smaller building blocks like glucose or amino acids. And so carbohydrates are broken into monosaccharides, proteins are broken into amino acids, and fats are broken down into fatty acids and glycerol. And so here you can see the site where the action occurs. So for carbohydrates, it starts in the mouth. And so here we have salivary amylase that is found in the saliva that breaks down starchy foods into their monosaccharides. The small intestines continues that breakdown using pancreatic amylase. And then the small intestines also has their own brush border enzymes that break down specific carbohydrates. protein digestion starts in the stomach and continues on into the small intestines. So in the stomach, we have pepsin, which is in its inactive form normally called pepsinogen, but in the presence of hydrochloric acid, it becomes activated and can break down proteins. Then we have from the pancreas, we have trypsin, chymotrypsin, and carboxypeptidase. And we have our own brush border enzymes in the small intestines also to help break down proteins. And then we have fats. Fats are going to be broken down in the small intestines. For fat digestion, we first have to basically emulsify the fats using bile. So bile salts attach to the fats and allow them to be able to be interactive with water. And once that happens, then the bile can interact with the watery environment. And most of the bile is going to be absorbed into the lacteals, lymphatic lacteals. But some of the bile will get pulled into the capillary beds of the small intestines and transported to the liver. If they go into the lacteals, then that will also get transported eventually to the liver. Just a longer about direction. So other really important functions that we haven't talked about, I mentioned, is absorption. So we have to take in the nutrients. So the products that are broken down, the materials that are broken down into their small subunits, the end products, have to be absorbed into our blood or lymph. And this occurs in the small intestines, mainly in the jejunum. And then once all absorption occurs, then in the large intestines, we're going to absorb extra water, producing a more compact ball of material called feces that will be defecated. And so pooping, or the elimination of the undigestible material and bacteria, is the last function of the digestive system. So if we look at the mouth a little closer, the mouth is the area for ingestion, where we put food in. This is where we start the physical breakdown of the food that gets mixed with saliva, and the salivary amylase begins starch digestion. So no absorption occurs in our mouth, but that food, that solid food that we took in, becomes a soft ball of food called a food bolus. And that food bolus then is able to be swallowed in two basic phases, the buccal phase and the pharyngeoesophageal phase. So here you see that buccal phase where we have the food in our mouth and we chew it up. We have this food bolus, and our tongue helps to push the food to the back of the mouth. This is the voluntary phase of swallowing. Once the food hits the back of the mouth, we no longer have control over it. Have you ever been sucking on a piece of candy, or we're chewing on a piece of gum, and it hits the back of your mouth, and then all of a sudden you swallow it down and you didn't mean to? That's because once it hits the back of the mouth, once it gets to that throat, then you have an involuntary reaction that causes you to swallow it the rest of the way down. So this is the first step in swallowing. And so in this step, the upper esophageal sphincter is closed. The food bolus is here, and we're starting to push it to the back of the mouth. The second step, pharyngeal esophageal phase, is an involuntary step. In this case, the food hits the back of the mouth, and immediately the upper esophageal sphincter relaxes, the epiglottis closes, the uvula raises up and covers the nasopharynx, and the food goes down from the mouth into the esophagus. As soon as that food moves past that upper esophageal sphincter, the sphincter contracts again. And the food now is in the esophagus, and it's moving down your esophagus until it hits that lower esophageal sphincter, or the cardioesophageal sphincter, where it's going to have to open so that the food can enter the stomach. And so food moves towards the stomach in that last phase, and then the sphincter opens and food enters into the stomach. So once food enters the stomach, now gastric juice is going to help in breaking down the food further. So gastric juice is produced in response to the smell of food. So neural regulation stimulates the gastric production. As soon as we start smelling food or we think of food, then our stomach will start producing gastric juice. We swallow the food down, and in the presence of the high pH that food causes, we release more gastric juice. So gastrin is released, and gastrin stimulates gastric juice production. And gastric juice includes your pepsinogens, your hydrochloric acid that activates your pepsinogens, and mucus that protects your stomach lining. So hydrochloric acid makes a very acidic pH, but that activates the pepsinogen, converts it to pepsin, which is what we need to break down proteins. This high, or this very acidic low pH, also provides a very hostile environment to potential pathogens. And so pepsin will start breaking down normal proteins. In infants, renin is a protein that is found in the stomach that digests milk proteins, but this enzyme is only found in infants. So food in the stomach is going to be moved via peristaltic waves, as well as grinding. So we move food back and forth in the stomach, and this can take hours, where we're just continuously moving food back and forth. And then once the food gets into that pylorus, and the small intestines is ready for it, the small intestines will release, or I should say the pylorus will release very small amounts of chyme at any given moment. So each release is only going to be about 3 milliliters of chyme. And so the majority of the liquid food stays in the stomach. And that food will stay in the stomach for about between 4 and 6 hours, depending on the amount of food, and just be released out into the small intestines in small amounts until it's all gone. The reason for this, if you were to, so I always ask this as a question in my face-to-face classes, but if we were to release all the food that went into the stomach at the same time into the small intestines, how much of that food would we actually be able to absorb or take in? How many of the nutrients? We'd lose a lot of nutrients, because only the things that touch the walls are actually going to get broken down and absorbed, which means a lot of food would go right through and not be absorbed. Also, food would move more rapidly, because we have so much more in our small intestines, that we'd end up losing fluids. And in the end, we'd end up having very runny stools. So there's a reason for everything our digestive system does. And so here you can see peristalsis of food moving. You can see that the food has been broken down into a liquid known as chyme. Here we have the grinding where small amounts of the chyme are released through that pyloric sphincter. So only about 3 milliliters are released at any given time into the small intestines. And then that that pyloric sphincter closes and the food gets moved back and forth some more until we're ready to release a little more via grinding. So what happens in our small intestines? Let's look at that. Once the first little amount of chyme enters the small intestines, it stimulates the small intestines to release two hormones, cholecystokinin and secretin. So you can see cholecystokinin is in the red dots and the secretin is in the blue dots. They both go into the bloodstream. Cholecystokinin stimulates the pancreas to secrete pancreatic juice. Secretin stimulates the pancreas to secrete bicarbonates. So we need bicarbonates to increase the pH of the stomach because, or not of the stomach, of the small intestines, because the chyme is very, very acidic. And then we need the enzymes because the enzymes are going to help in breaking down all the liquid food chyme. Secretin also stimulates the liver to produce and secrete more bile. Cholecystokinin stimulates the gallbladder to release the stored bile that is in the gallbladder. These are going to move, the bile is going to move down and release through that bile duct into the small intestines as well. The vagus nerve also stimulates our pancreas to release pancreatic juice and stimulates contractions of the gallbladder. So all of this together is going to start the digestion, chemical digestion, and the absorption of nutrients in the small intestines. So here are some hormones that are, here are some hormones associated with our digestive system. Here's where they're produced. Here's what the stimulus for secretion is and the action. And so there's two different tables. I'm going to let you read those on your own. And then we're going to look at the end product. So what happens? Chyme breakdown and absorption continues through the small intestines. The materials in the small intestines are going to be absorbed either via diffusion or through active transport. And the majority of the materials are going to move into the liver via the hepatic portal vein. But some, specifically some of your lipids, are going to be taken into the lymphatic system and dumped back into the blood through that thoracic duct. And so in the small intestines, material moves via peristaltic waves as well as segmentation, just like in the stomach. So here again, we see the peristaltic waves, and here we see the segmentation. Once the materials hit the large intestines, the majority of absorption has occurred, but there is going to be some absorption of water and vitamins remaining. The vitamin K and vitamin B, or I should say vitamin K and some vitamin B, are going to be produced via bacteria in the large intestines, and then those are going to get absorbed as well. Anything left over after the absorption in the large intestines is eliminated as fecal matter, which mainly is bacteria, undigested food, some mucus, and water. So in the large intestines, we don't have so much peristaltic waves. Peristalsis is very sluggish. So instead, the material moves via haustral contractions, which moves the material from one section of the large intestine to the next, but mass movement actually moves materials roughly 3 to 4 times a day from the large intestines, or from one area of the large intestines through those large intestines to another major area of the large intestines. And this actually can lead to defecation. Most mass movements occur directly after a meal. So we have a meal and then we're going to get rid of the food that's in our large intestines so that we can move the food that's in our stomach into the small intestines and the food that's in the small intestines into the large intestines, which makes sense. So movement of materials into the rectum stimulates the defecation reflex. And so we have two different sphincters in our rectum. We have an internal anal sphincter, which is up higher. And when that relaxes, it stimulates our voluntary sphincter to want to relax as well. And that stimulates us to want to poop. So at this point, there's a lot of stuff you should have learned. What is ingestion? What is peristalsis? What is mechanical and chemical digestion? Where does carbohydrate digestion start? Where does protein digestion start? Where does fat digestion start? How does swallowing occur? What stimulates the stomach to produce gastric juice? What stimulates the small intestines to secrete cholecystokinin and secretin? What's the portal system that sends nutrients to our large intestines? And what is the major function of the large intestines? I did just say that. Oh, the absorbed nutrients travel to what organ? So what is the organ that all nutrients travel to initially? And what portal system sends them there? And then what is the major function of the large intestines? And how does movement differ in the large intestines from the small intestines? So this is a longer video. I'm going to stop it and then we'll get into hopefully our last or second to last video. Bye.